Hello, my name is Aleksei Gladkii. I'm a PhD student at Supercomputer and General Informatics Department at Samara University. The work that I'm going to present to you was carried out in collaboration with Danilo Shkerdov, who is also a PhD student at Samara University. I imagine many of you read some news articles about hackers breaking into some system, or some service being unavailable due to cyber attacks. Let me tell you about one of these attacks. Several years ago, DNS provider named Dean was attacked by a botnet of thousands of smart devices, hacked with Mirai malware. This attack was the largest DDoS attack in history, shutting down half of the internet, including services like Facebook, Twitter, and Amazon. This attack showed that weak security of smart devices can cause serious disruptions. So, what can we do to make smart devices secure, and where do we start? In my presentation today, I'll be proposing the design of Internet of Things Honeypot that simulates HTTP-based smart devices. I have divided my presentation into three parts. In the first part, I'll give you an overview of Honeypot technology and how it could be used for improving the security of IoT devices. Then, in the second part, I'll describe the design of IoT Honeypot and its functional components. In the final part, I'll talk about the proof of concept implementation and future research. Let's start then by talking about honeypots. Honeypot is a bait for hackers. It substitutes a real device with its equivalent that has tools for collecting and analysis of attacking requests. A honeypot is anonymously exposed to the internet, and since then, honeypot starts collecting requests. There is a high chance that these requests will be malicious, since this device can be discovered only with scanning of global network address space. Captured requests can then be used for analysis of attack strategies and malicious code, and further development of countermeasures. Now that we have seen what a honeypot is, let's look how we can build a honeypot that simulates Internet of Things device. IoT devices are heterogeneous, and they communicate via many different protocols like CoAP, HTTP, MQTT, and others. In this work, we will be focusing on simulating devices that communicate via HTTP, since HTTP is widely used in IoT environment. Now, let's look at the conceptual design of an IoT honeypot that simulates HTTP-based IoT devices. On the left-hand side, we can see that requests first go to the NAT device that dynamically maps a local address to a global one. NAT is used here because all real devices are deployed behind NAT device, and also because NAT allows us to hide the structure of the internal network from attackers. On the right-hand side, we can see a server that runs a Linux-based virtual machine. Virtual machine is used to create an isolated safe environment that can stop viruses from infecting the whole system. Linux is used because most of IoT devices use Linux, and we want our honeypot to be indistinguishable from the real device. Inside of the virtual machine, we have Nginx HTTP server. It is used to proxy all the requests to a REST API module and to conditionally log them. We also have a REST API module inside the virtual machine. This module simulates a communication interface with the device. We don't need to develop full emulation of the API, because usually device scouting is performed with automatic scanning of network responses. If the initial response indicates that the device is an Internet of Things device, then hackers' bots start sending attacking requests. So we need to implement an API so that only the initial response is indistinguishable from the response of the real device. Then we have the controller that runs outside of the virtual machine and fetches network interaction logs. This is done for log safety in case of problems with virtual machine or virtual environment contamination. Then, controller sends logs to the store module. We can use any kind of storage system, for example a relational database. And the final module of our Honeypot is the analyzer that can run intellectual data analysis algorithms on network interaction logs to detect malicious requests. Now, I would like to move on to the final part of my presentation today, to discuss the proof of concept and further development. We have implemented and deployed proof of concept Honeypot that simulates Philips Hue lighting system. We used Express.js to build REST API module and MongoDB for storage module. Just in 2 hours after the deployment, our Honeypot started receiving attacking requests, what proves the viability of the proposed design. We intentionally do not present data analysis results because our Honeypot has been operating for a relatively short period of time, so the analysis results would not be valid. We believe that the proposed design can be used as a methodology for building HTTP-based IoT honeypots. In the future, we're planning on giving an analysis of captured data and malicious code, and developing an efficient IoT security system. That brings me to the end of my presentation. So, just to recap, let me go through my main points again. We have seen that a honeypot is a bait for hackers that can be used for attacks detection. We also saw that the proposed design can be used as a universal methodology for building HTTP-based IoT honeypots. Finally, we discussed that our proof-of-concept implementation of the honeypot proved viability of the proposed design, and we also discussed that we are planning on using data from the honeypot to build an efficient IoT security system in the future. Thank you for listening. If you have any questions, I will be happy to answer them for you in the comments section or via email. You can find my email address on the final slide.